Welcome to SketchPath, using digital drawing to integrate the gestural qualities of craft in CAM-based clay 3D printing. My name is Devon, and I'm presenting this work on behalf of my co-authors, Raina, Eun-Ha, Paek, and Jennifer Jacobs. Additive fabrication is a growing area of manufacturing that integrates new technology and materials to generate unique forms. Traditional additive manufacturing design processes involve designing the form through a CAD tool, preparing that form for fabrication through a CAM tool, and then fabricating the form with a digital fabrication machine. Computer-aided design, or CAD, tools allow a user to design a form by describing the solid geometry of that form. The focus on form results in machine and material agnostic designs, limiting the potential expressiveness of the material and machine interaction. These limitations are particularly present in clay 3D printing, as clay has such rich material properties. An alternate design workflow involves skipping the CAD step and designing directly in CAM tools. CAM design tools allow the designer to create forms that are specific to the machine and material in use by designing at the toolpath level. This allows for unique material outcomes, such as the droops seen here on this clay vessel designed by Studio Sando, or on listening cups where audio data is encoded in the toolpath through the printing procedure. HCI researchers have developed CAM-based design systems to capitalize on material and machine properties. Examples include P5.fab and Bespide for plastic printing design, and CoilCam for clay 3D printing design. These tools are built for programmatic form generation through text-based coding or node-based programming, while highly expressive, symbolic design tools are not accessible to many. Additionally, much of the innovative techniques for CAM-based clay 3D printing come from artists also developing specific workflows in node-based scripts such as Grasshopper. While highly expressive, these programmatic CAM-based design processes are misaligned with manual skills required by traditional ceramic practices. CAM-based design processes rely on altering symbolic characters to create toolpaths, rather than on an embodied design process. Observing this misalignment of ways of work led us to develop SketchPath, a direct manipulation tool for drawing the toolpath of a form to be clay 3D printed. Our goals with this work were to support CAM-based design through direct manipulation, enable skilled manual artists to intuitively develop forms through an embodied process, and to lower the barriers to CAM-based design while maintaining expressivity. With SketchPath, the artist draws the exact toolpath the clay 3D printer will follow when it prints the form, working from the base of the form up to the top, just as the printer does. This provides control over the toolpath, surface texture, and form development through a graphic representation and a direct manipulation interaction. The system consists of a simple web-based interface containing a drawing canvas, a 3D toolpath preview that allows the user to see the form as it's developed, and computational transformation tools that allow precision manipulation of hand-drawn layers. We introduced these computational transformation tools to reproduce procedural manipulations seen in symbolic tools. Transforms allow the user to procedurally copy any existing layers to be duplicated, scaled, rotated, or moved. This allows for the rapid generation of computationally precise repetition of form and texture. The locking tools allow users to specify areas of direct locking in purple, where when drawing subsequent layers, they will be constrained to create a direct trace of the layer below in order to create precisely stacked walls. The symmetry tools allow users to create forms with multi-axis rotational symmetry. We also support mirrored symmetry. This work was evaluated through a 3-month clay 3D printing residency we ran in our lab with 2 professional ceramicists, Raina and Eun-Ha. Both used SketchPath throughout the residency and provided continual feedback about their experience with the system. This resulted in over 35 final fired objects designed with SketchPath and multiple reflections and discussions which we analyzed. With both residents and myself using SketchPath, we developed a range of aesthetic outcomes and methods for designing forms. We found that SketchPath supported an emergent design process, meaning it allowed us to develop forms iteratively through the drawing process rather than starting out with a concrete idea of the final outcome. For example, Eun-Ha played with progression of trace lines in symmetry mode to create a bowl, and Raina designed various flat pictorials exploring the layering of elements and how they evolved into scenes. We found residents were much less likely to use SketchPath for executing pre-planned forms. However, we did observe some examples. This image shows a picture designed layer by layer in SketchPath by Eun-Ha. Through our collective use of SketchPath, we generated forms with varied aesthetic outcomes. When drawing forms, we often saw this wavy surface texture with the imprecise stacking of lines that would be hard to produce in symbolic tools. Something we found really intriguing was the computational repetition of hand-drawn qualities. Here, Raina drew 15 layers, then repeated them 3 times to create a vessel. You can see the top of those 15 layers is smaller than the bottom, and the repetitions create repeated drooping down the sides of the vessel. We were also able to create more precise textures similar to symbolic cam outcomes. This form has one rotationally symmetric layer repeated to create precise textural stacking and drooping. This next form has 2 hand-drawn layers repeated to create this alternating surface texture. Eun-Ha in particular noted that the precision detail made SketchPath a good alternate to hand-building organic forms with high precision detail. One of the most important outcomes of this work was creating a system that lowered the barrier to CAM-based design while maintaining high expressivity. Raina was a complete newcomer to clay 3D printing, and during the residency, she was able to learn various computational tools, but SketchPath allowed her to immediately create complex and varied forms with low learning cost. This ease of use was also reflected in both our residents' drawing forms during meetings or reportedly while watching TV, as the drawing was a casual design interaction with low mental cost. While the ease of use was a factor that influenced rapid adoption of SketchPath, the factor that resulted in continued use was the expressivity of the tool. Artists value the ability to enact uniqueness, and SketchPath designs depart from the common geometric outcomes of programmatic design tools. Both residents were intrigued by the mixing of hand-drawn and computational qualities and how they were able to reflect their own artistic aesthetics directly through hand-drawn lines. Drawing specifically is a powerful direct manipulation tool for expressivity, we found. To our knowledge, SketchPath is the first CAM-based design tool with a drawing interface. We believe this research suggests future opportunities for rethinking the ways in which we can integrate manual skills and digital fabrication. Drawing has different qualities from manual clay sculpting. However, both processes enable the expression of form through tactile and embodied actions. SketchPath demonstrates that it's feasible to support such interactions in digital fabrication while retaining much of the expressiveness that is feasible through numeric and procedural methods. This makes us hopeful for the future expansion of interaction modalities in CAM-based design. Thank you.